Hey guys, it's Mr. Watt. So by this point in class, you know that we've been looking at speeds and velocities. So if you can figure out what a certain distance covered is, and you can figure out the certain amount of time that that distance gets covered, you have the ability to figure out a speed or velocity of any particular object. So normally in class, I'd be doing an experiment like this, but I figure that instead of doing that, let's use the world as our way to determine what speed and velocity can be. I'll show you how. So the question is, how exactly are you going to be able to determine a specific distance over a specific time in anything that you have? Well, for example, we'll use my neighborhood. This is my neighborhood. This is my sidewalk, my street. If you took the sidewalk and you used it, each of the sidewalks, and probably same thing near you, you can find a sidewalk where your sidewalk is divided into what looks like squares. And they're really rectangles, but we'll say squares just to keep it simple. All you gotta do is take something that you can write with, perhaps chalk, perhaps you can use tape, maybe you can use a rock, and all you have to do is create a start and a finish line, just like this. So taking those pieces of chalk, what I did is I created a start line right here. And you see what I did along the sidewalk, and I'll walk you along the sidewalk. My little motivation for go, 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 until you reach the finish line. Now you're probably wondering, why did I create a start and a finish line on both sides? Well, I did that on purpose because depending on who walks on the sidewalk, depending on what distance they come from or what direction they come from, I can accurately calculate what their speed and their velocity would be. Okay, so now we're located inside my office where I teach class from. And as you can see, we got a great perspective of the track up here. In fact, you can see there's that finish line close to where the tree is, or starting line. And here's the start and finish line right down outside my window, right next to the driveway. So now we have everything set. The only thing we don't have is a timer. You can use any kind of timer that you want. If you want to count 1 1000, 2 1000, 3 1000, 4 1000, 5, and kind of make an estimate of what the time is, you could do that. Or if you have a cell phone, like I do, you can just use the stopwatch function on it. And then basically all you need to do is start it when the time is right, and then let them do their thing, and then when they stop, you can do that. And everything works out perfectly. So now the final piece to this puzzle is waiting for a person to come by. And as they approach either the starting line that you see right behind the tree, or as they approach the starting line that you see right here at the edge of my driveway, then we can use our timer and we can start and stop it once they cross the line, depending on which way they're going. I'm sure once we get some people out there, I'm sure we're going to get some people kind of curious to see what that's all about. I've been here for about an hour. Of course, it's early in the morning, and as you can see, except for the occasional car down the street, I don't see any person around here. So I'm going to actually walk this thing myself and time it. Out of the view of the camera, you can't see it. I've got my timer set, and go. Here I go. I'm just a hiking. Just doing my normal walk, and I'm coming up and stop. So now I'm at 11.08 seconds. Having completed my experiment, I've walked 10 squares in 11.08 seconds. I can use the formula for speed, and I can do the calculation of 10 squares over 11.08 seconds. And when I do it on my calculator, you see how I got that 0.902 on there. But based on what I've been telling you in class, I can round that down to 1 decimal. So it's going to be roughly 0.9 squares per second. So there you have it, everybody. Very simple. All it took was a piece of chalk, took a little bit of time, a little bit of thinking, and a lot of videography in order to make this project work. How would you do the same thing? So here's the challenge for you. It's extra credit, it's worth extra credit, and it's due by next Friday, May the 8th, into your shared drive folder. What I challenge you to do is not necessarily duplicate the same thing that I did, but rather come up with an idea of how you could demonstrate speed in the real world. Use your family, use your siblings. How would you teach your siblings about speed and what we're doing in class, using the methods that we just mentioned right now? Whatever you want to do, it's up to you. It's due on Friday and would be worth some extra credits. Thanks for watching. Good luck. Ciao for now.